Alright, good morning.
Good morning.
I have a bogus time here. My cam is stuck. Let's reset that. Cool. Alright, well, this is the end of week 6 today, so week 7 starts next week. This is a crazy fast quarter. Alright, send me an attendance note. There you go. Let's see who's here. And so, PA3 looks like about a quarter of the class is continuing to work on it. So, if you have questions about the high-low game, let's talk about them. Because I'm probably not going to be very chattable over the weekend. But questions on PA3, high-low, putting functions together, make files.
So I have a question. And I managed to get this fixed on my program to be able to submit it, but I couldn't figure out a logical operation to put in the while loop to continuously check for if the user entered only an H, L, or C. So while I was trying to put it in, it would do things like, it would check the first character, but it would ignore the rest of the characters. So if you type down like haha, it would only capture H and haha and accept that as a acceptable letter. So
Okay.
my question is, what is the proper way to check for user's input, or what is your way of checking for user's input and have error checking?
Okay, so in this case, we're not parsing an int. We're looking for a particular input string, and we want them, for example, to type just an H followed by the enter key. And so if we're doing an fgets, and we say something like fgets temp length of the array input stream. The easiest way is to recognize that if the user types H followed by an enter, temp is going to be a string containing exactly 2 characters, an H followed by a new line. And that's one thing fgets does. It always tacks a new line on the end after the user's input. So we could say something like if 0 is equal to string compare of this string and temp. And then we can say user entered an H. And if this is in your getAnswer function, what do you want to do if you detect that the user types an H? You could just say return the character H. And then you could do the same thing to see if they typed an L followed by a new line. Then you could do the same thing to see if they typed a C followed by a new line. And then you could put all of this in a while loop. And this will print a prompt. Wait for them to type something in. This will tell you if it was an H. If it is, you'll return the character H. If it's an L, return an L. C. Otherwise, you'll go back up to the top of the loop, and you'll keep asking them. So that's one way to loopify that, and to do the checking.
Well, I did a very push, but where I didn't use string compare at all, because I figured out that's the thing.
Okay.
So my alternative way of doing this is that I put down like if the first character in a string is equal to H, C, or L, then return that value. Otherwise, it would go into a while loop where as long as it does not equal H, C, or L, and it's not only one character, it's going to keep asking the user for the input.
So that's exact. Sorry, go ahead.
So, but the problem is that I ran into logical errors where, you know, you can type down anything you want, and eventually the computer's gonna accept it, whatever you input in. So I was using like what I learned from CSE215 and kind of like play around with logic a little bit, see if I can actually get where I don't get any like logic errors.
Mm-hmm.
But it was difficult. So
Yeah.
the best way I solved it was I made like a toggleable flip called repeat, which switches between 1 and 0. So as long as it's 1, the loop's gonna repeat. If it's 0, it's gonna get out of the loop and return the correct string, which is kind of weird, but it works.
No, that's perfect. That's what we call a flag. That's exactly that's a great example of using a flag where we set something in a variable, and then later on we act based on the value of that variable. So that's a good way to do it. And yeah, you can check temp 0 to see if it's an H, and that'll tell you if what they typed in started with the letter H. You could also then check to see if character 1 was a new line, or you could check to see if the entire thing they typed was equal to 2. And if it starts with an H and it has a length 2, you're guaranteed it's an H followed by a new line.
Yeah, that's exactly what I was going to say.
Yep, that should work too.
It made my project way easier if I could just string length instead of like finding alternative ways to do it.
Mm-hmm. You could also check to see if temp bracket 2 was equal to a null terminator. And if you know there's an H and you know it came from fgets, so it has at least 2 characters, and this is a null terminator, then you're guaranteed that the length is 2. And you can use %C to grab a character, but there's almost no reason to do that unless you're parsing in the middle of something bigger, because if we want to grab the character after the first one, we can just do bracket 1, or you could do a scanf with a %C. But it's kind of the same thing. And then somebody noted in the chat that if the user types in more than 120 characters, you will not see the new line. What will happen is fgets will take the first 119 characters the person typed, put those into temp, and then append a null terminator to the 120th character, and you won't see the new line yet. So that's okay. Yeah, if someone were to come in and spam your input with 1,000 characters, then you would get 10 iterations through your loop, each one saying please enter an HLC, please enter an HLC, and it would sort of work its way through that input in chunks of 120 characters. That's hard to avoid, that kind of behavior, because we're using fgets instead of gets, but that's an important thing to be doing. So, and I'm not going to egregiously try to break your code by doing a buffer overrun or typing in 10,000 characters or something like that. So, all right, good. What else?
So I ran into a problem that I couldn't really fix before I turned it in.
Mm-hmm.
With the cheat detector, where if you continue to hit H, it would basically continue no matter if even if guess equals 0 and you continue to hit H.
Mm-hmm.
And so I found that you have to hit L once in that string of H's in order for it to work.
Okay.
So you show us what the correct
Yeah. So it's
what the cheat detection is supposed to be.
it sounds like either an issue with the actual check itself or an issue with how you're adjusting high and low. So our algorithm is put the guess in the middle, and this will tend to round down as long as everything's non-negative. So if it's, 1 and 2 is 3, it'll round down to a 1 for the guess. And then if the guess is high, change high, and here's the important part, you got to change it to guess minus 1. And if you just change it to guess, that won't work.
Yeah.
And if it's low, then change low to guess plus 1. And then any time that you change low and high, low or high, do the following check. If low is bigger than high, that's an error. So if you've got it sandwiched down to 1 or 2 spots, let's say low equals 0 and high equals 1, it's going to guess halfway in between 0.5, that's going to round down to a 0. If you tell it that 0 is high, then it's going to change high to be 0. Oh, let's see. Oh no. So you tell it that your guess is 0. If you say that 0 is high, it's going to change high to guess minus 1. This is going to become minus 1. And then when you do this check, low bigger than high, it should at that point say, hey, something's wrong.
Yeah, it does do that eventually, but it doesn't guess that you're. It doesn't trigger the cheat. I feel like the cheat detection should trigger sooner, but
right.
It doesn't. So it's below on mine.
Let me take a quick peek. Behavior my program 2 as well as temp PA3. Well, let's try that. Because if that's happening in the sample code, that's a bug, but if it happens in the sample code, you're allowed to do it.
Well, I don't think it's a bug, it's just that when you enter a billion characters, it just, runs through the check where it asks you for it.
Oh, okay. I thought you were talking about needing to cheat twice or something. Yeah. So this is expected behavior. If you do that, I have a really slow repeat. Uh-oh. Did I crash the server? I think I crashed the server.
Unlock it.
Well done.
Excellent.
Oh wait.
Oh, it's back.
Mine isn't crashed.
It was just thinking about it.
Before it and this.
Huh. Wonder how many people are logged in.
You're kind of cutting out, so it might be your internet.
Yeah, I'm not logged in, so I'm just saying that.
Okay, yeah, I think it's probably my internet.
Yeah, because no, it's not mine. I've got gigabit at work.
Okay. Yeah, so this is expected behavior. If you type in a bunch of things and it's longer than your buffer size, it will take it in chunks, and each time you'll get a repeat of that error message. So that's totally fine. All right, and in the cheat detection, right, you need to, if any time that you change high or low, right, you need to check for cheating before you ask for another answer. So if I make this change and then I say, is that high or low, before I've checked this, then you'll see that behavior where it's taking an extra input before it calls cheating. So just make sure that you do this once you change high and low before you do anything else, right? Because it's once you've modified one of these that you can detect if something is wrong. So the program should not accept a range that's less than 0. If you put in two numbers where the first one was, if you did something like main, 200, 100, which is not supposed to be allowed because the second one has to be bigger than or equal to the first one, or maybe something like main negative 100, which means you're playing between 0 and negative 100, that predict function will mess up, right? But you're not supposed to accept this anyway. The high has got to be bigger than or equal to the low. But if you try to take the log of a negative number, you get negative infinity, I think. And so you'll get some big long negative number for the number of guesses. All right, other questions?
I always miss one thing like that on these assignments after it's done.
Hey, that's not bad. I don't know if I'll even remember to check for negative arguments. Yeah, I don't know. We'll see. All right, other questions? All right, well let's talk about more Linux stuff. So we've been picking up a lot of Unix stuff, just kind of like in the course of talking about whatever we've been talking about, and we haven't really sat down and gone through a list of Unix commands one by one or something like that, and I'm not really planning to do that, but I want to talk a little bit more about a few commands and just kind of expand on some concepts related to Unix. The first one being this notion that everything in Unix is a file, and this is a pretty key point, and it's not true of all operating systems, but in a Unix environment, right? Pretty much everything that you deal with is a file. So let's just take a look at a typical system. So obviously, I have files in this directory, and some of these files are directories themselves, right? But if I do an ls-l, let's pick a directory. So work, right? Work is a directory, but it's also a file.
Are those
And
r-synced files?
are those what?
R-synced files, those little arrows next to them?
Those are links. So we're going to talk about links too. It's saying OL is a link to this thing. So,
Okay.
and that L in the beginning tells you it's a symbolic link. So we'll talk.
Some links are so cool.
Yeah, they are.
To the sudoers file on the server.
Say that again.
Could I link to the sudoers file on the server and bypass permissions?
You can link to it. I mean, you can run it. You can try to edit it, but it's really just a reference to that file. So if you try to edit it, it's gonna treat it with the same permissions as if you just edited the file directly. So yeah, that doesn't get you around it. So work itself is a file, and you know, if I try to VI it, it tells me it's a directory. But I mean, it's a bunch of stuff stored on disk associated with a file name work. I don't think I can do this. Nope. All right, so these are files or directories that contain other files. If I go into /dev, that's short for devices, I see a bunch of files in here. And these files, you know, have funny names like net, right, which is a network portal, basically. TTY, that's my terminal that I'm reading from and typing into. So if I take cat and I redirect it, or if I take date and I pipe it into TTY, right? Oh, that's a bummer. Date and I redirect it into /dev/TTY. It shows up on my screen because TTY is the device that's connected to, you know, my keyboard and my display, right? It's if I do an ls-l, this first character is C. That means it's a character type device. This can be a C or a B. B or binary, C are characters. And so we have all these different devices. We have you know, virtual hosts. We have video interfaces. We have something for generating random numbers, I believe. We have our USB ports. Devices that are used with VirtualBox to let VirtualBox interact with our hardware. Video for Linux, V4L, is a directory that has a bunch of stuff in it, and so on. But these are all just files, which means if I know how to work with files, if I know how to use fopen, fgets, fprintf, fclose, I can interact with hardware the same way that I interact with, you know, just a plain old file on disk. And there's even a file called mem, which is the memory of the computer. I don't think it's actually mapped to the memory anymore, but in earlier versions of Unix, this was actually, you know, a way to access your memory byte by byte, as if it were a file. And so this is useful because, you know, you don't need special commands or special functions to be able to do something like, you know, send the characters to your console or to a USB port, right? Really all you need to do is open that thing up, and if you want to send information to it, you can just do an fprintf, and out it goes. So my first Linux system, you know, I thought this was good fun, and so I think I looked at the disk file, and, you know, I gave myself permission to write to it, and I just, you know, wrote the word hello into this file, and that was the end of my first Linux system, because I had just, you know, obliterated the hard drive. So it's really that easy, you know, which is great and also terrible. And you know, because everything is a file, and because files are controlled by these permission bits basically govern the whole kind of security of the system. And this disk file is readable by everyone, but it's only writable by the owner, who is root. So unless I make myself root by doing something like, you know, sudo, I can't write into this file. But if I have root access, yeah, I can write into it, and whatever happens, happens. So I think this was the old floppy drive, back when we had floppies, and so on and so forth. Now, if I do a df command, df shows you your disks, right? And I have a few disks on here. I have this thing called external backup, which is this 2 terabyte drive. And that's under /media/nic/this directory. And that's actually a network drive. So that's like my outside running backup. But /, which is my main root system, that's the really fast, not SD, but the one above SD card in the laptop. That's listed as /dev/ this big long thing. And if I look at that, right, that's just another device under /dev. It's a binary device. It by default nobody has access to it except the owner and the group, who can read and write, right? But that's my MMI or whatever it is, hard drive built in. /HDD is the slower, but still really fast SD drive that I have, the solid state drive, and that's under /dev/SDA. But it's just a file, right? I could open that up and I could just start looking at its contents, or writing it. So everything is a file, right? And files are controlled through these permission bits. And so, for example, the network interface, by default, root's the only user who's going to have access to that. And so if I want to open up a network connection, I do that through the operating system. The operating system has root access to that device. It will take care of you know, opening that device, sending things, reading things, and so on and so forth. But it does that on my behalf. And we generally, as regular users, don't have direct access to most of these devices. TTY being one exception, because that's our terminal. But you know, if there were multiple users, they might come in other TTY devices, and I wouldn't have access to those. And a lot of this stuff is obsolete, but sort of left in for compatibility purposes. We don't really have physical TTYs, teletypewriters, connected to our Unix system anymore. We have pseudo terminals, so these are just kind of legacy. Here's standard in, standard out, and standard error, and they're just devices. Now they link to other files under different directories, but that's where our usual input and output systems are. Null is a good device. So what does null look like? Right, it's got nothing in it. And I can write things into null. Right, and they just disappear. If I look at dev null, it's still empty. So that's the bit bucket. Almost every operating system has some version of a bit bucket. So on Unix, it's /dev/null. It's a device that anything you write into it just disappears, and anytime you try to read from it, you just get end of file. And that's surprisingly useful. If you're running a command that generates output, but you don't care about the output, you can just redirect the output into dev null, and you never have to see it.
So it just deletes it, or?
It mostly just ignores it. So if I copy, you know, my bash rc into dev null, it reads all the bytes out of this file, and you know, it opens this up and writes information into it, but nothing happens to those bytes when they're written. It's basically a no op. So in college, my friends and I were going to make a band called the Null Devices, where we were just going to be a different null device from a different operating system, because it's NLA 0 on some systems, and every OS seems to have one of these, and they're useful even though they're nothing, you know. But you know, if I were to copy /dev/null into ~/.bashrc, well, I've just truncated that file to 0 length, because as soon as I read this, I get end of file, and so it would read nothing, and it would replace this with an empty file. But that's one way to truncate a file. So with the ODPs, after I download and process the grades, and I want to clear out the grade file, I usually just copy dev null into grades.txt, and then I've got a clean slate.
If you want to clear it, couldn't you just do : greater than?
Yeah, if I VI it and then I :1, $delete, that would work.
You can do it in Linux. You don't have to even VI it.
So what would you do in Linux then?
Colon greater than, and then the file name, it just clears the entire file.
Like that?
Yeah, exactly
Huh.
like that.
I'm not familiar with what colon does.
Yeah, I don't know. One of my coworkers just told me about it, but yeah, colon greater than, and it'll just delete.
Interesting. I don't know what colon's doing, but it's doing something. So maybe it's a null command or something. That's cool. It's a good, nice trick.
Yeah. Now that I know a bit more about piping and whatever, it probably just pipes nothing into the file or something.
Yeah, yeah.
Writes it.
Cool. All right, so let's see what else have we got here. Everything is a file, right? So if you go into /etc, there's a bunch of files in here. There's also a password file, which used to be where the passwords were actually stored. They're not stored there anymore. They're stored somewhere else. But this used to be just a username, a password, I think user ID, group ID. I don't remember what that was. Your home directory and your shell. And this file is still used. And mostly the files in here are used by other programs. So for example, when someone tries to SSH into this laptop, the program that's listening for SSH requests will look under etc for this file host.allow, and will do certain things with that, or things like that. So these are mostly just plain files or directories containing other files. And /etc is a system directory. It's usually not something that users interact with directly, but it's where information about the operating system itself reside. So looking at files, you've got options. So cat is the most straightforward way to look at the contents of a file, right? And that just throws it out to your screen. More will show it to you one screen at a time, and it shows you you're 5% of the way through, and you can space bar through to see more of your file. You can hit a Q if you're done looking at your file. You can hit a question mark and see all the options you can use in this, so you can search for things, and you can go backwards and so on and so forth. But mostly more is just a way to look at your file without it scrolling off the end of the screen, and so you can just kind of go through one page at a time. And when you get to the end, it just exits. And a lot of people will use VI to look at files, and again, I suggest not doing that, because as soon as you VI a file, you're able to change it, right? And if I start trying to look through here and I'm not careful, I might accidentally make changes, and if I always write :WQ to get out of VI, I might disturb my file without meaning to. So there's better ways than VI to look at a file, and more is probably the most preferred one. And if you're in more and you decide you want to edit your file, you can just type a V and it'll pop you into VI at that point of your file, and then when you quit, you're back into more. So all these tools kind of work together and play nicely with one another, which is useful. All right, so file manipulations. So you can copy a file with CP. So copy old file to new file. That makes another file that contains the same contents as that file. If you want to rename a file, you can do move. And that basically changes the name of old to new. And if you want to delete a file, you can say remove, and that'll delete it. And if you're working in an area where you've got a Git repository, then instead of doing move, you should do git move, old, new. Instead of doing remove, you should say git remove file. Otherwise, if I just change the name of a file or I just delete a file, the next time git is invoked, it's going to say, hey, where'd my file go? You know, I had this thing called file, I don't see it anymore, I'm confused. Or it's going to say, hey, where's my file called old? I don't see that file anymore. So this not only does the move or the remove, but it also alerts Git to what happened. Otherwise, you've got to go in and separately tell Git, you know, here's a new file and so on and so forth. And you can do these on directories as well, because, you know, directories are just files. Right, so here's a directory called mydir. I could say, let's rename that to, you know, to uppercase mydir. All right, and I just renamed a directory. I can copy go3 to go. And now I've got a file go. It's got the same size as go3, but it was created 3 days later, the 29th instead of the 22nd. If I do move, then go is what go3 used to be, right? October 26th, 1021, well, that's this file right here. So it's actually renamed it. And notice, by the way, that when I did this move, it obliterated my previous version of go. So if I try to rename a file to something that already exists, it gets rid of the thing that already exists, and it just continues. All right, I can copy directories. But it's going to warn me, hey, you know, I tried to copy this file, make stuff to haha. Well, make stuff was a directory, so I didn't copy that. So if I do a copy -r, that should make a new directory named haha. And if I look in haha, there's my copy of the make stuff directory. So -r is a really powerful switch. Wow, thank you. And it means do things recursively. And if I had other directories inside make stuff, it would have copied the stuff in those directories as well. So it'll continue to recurse down a tree. And if I try to remove haha, it'll say you can't do that because haha is a directory. So I can use remove directory, haha, but it'll say the directory is not empty. So I can go into my haha directory and I can try to remove everything, but it's not going to remove ho because that's a directory. And if I try to remove that with rmdir, it's going to say that's not empty. So if you have a whole directory tree that you're trying to remove, it's hard to do by just saying remove or remove dirst, but there's a recursive option. I can say remove recursively, haha, and that will go down the whole directory tree and delete everything along the way. And that's a potentially dangerous command. Because if I was in the wrong spot, I just wiped out that whole directory tree. And if haha was the name of my main CSE224 directory, you know, I just wiped out all my work. But, you know, if that's what you wanted to do, that's good. All right, where are we? We got 10 minutes. Any questions so far?
My question is, if you go back to that that list of files with read and write on the left, can you kind of show me like kind of like a pattern of which read or write represents different people, like owner and others, etc.
Mm-hmm. So these are sometimes called the access bits, and it's basically read, write, execute, read, write, execute, read, write, execute. So this first group is the owner. That's the person who's listed, whose user ID is listed next to the file. So all of these files are owned by Nick. Okay, that's the owner. The next 3 bits are the group, and the group that owns the file is whatever name is listed here. So this is the group, and then those last 3 bits refer to the world. So anybody other than the owner or the group. So like on the Linux server, all of these files are owned by Nick, and the group owner is faculty. Right, this one file is owned by root, and the group is root. And so on this file, for example, the owner, Nick, can read, write, and execute the file. Anybody who's in the group other than me has read and execute permissions, and the rest of the world also has read and execute permissions.
So what's the difference between the world and the group? Like, what determines, like, how do you determine who's in your group and yeah.
So on my own machine, I belong to a number of groups. There's a group called Nick, administrator, dial out, CD-ROM, sudo, I don't know what dip is, LP admin, who can interact with the line printer, laser printer, and so on. And so my user ID is Nick, right? That's what I log in with, but my group can be any of these. So if I was working with a file and it was listed as being owned by, Billy Bob, but the group was NetDev, I would have group access to it. And the group permission bits would control what I could do to that file. If the file's owned by Nick and that's me, then it's the user bits, the owner bits that control my access to it. If it's not...
Is the facility, is that the group name? Or the group, kind of group category?
So this is the group owner of the file. This is the group that owns the file.
Okay.
Sorry, I'm watching my recycling get emptied into the truck. It's like really fun. Whoa. And now it's getting munched up. And there it goes.
3 feet.
Yeah. I've got a great view from my desk out the window, and the recycling truck just came by and picked up the recycling bin and dumped it. And it's something I haven't seen in years, because I was living in an apartment before. So that was kind of mesmerizing.
That's like the kind of alarm and all that.
Yeah, and it's just kind of like,
Yeah, I always find that amusing as well.
Yeah, totally. Alright, so yeah, so the owner of this file is Nick, the group that owns the file is faculty. And so every file you can set who's the owner and who's the group. And then, if Nick tries to access it, they'll be controlled by these bits. If someone other than Nick, but who belongs to the faculty group, tries to access it, they would be controlled by these bits, and anybody else would be controlled by those last 3 bits.
So while we're on the topic of this, what would the number 55911 mean in that list?
Which number?
The first digit.
Oh, this one.
Digit. Yeah.
That's a dang good question. Well, it's not the number of files. I actually have no idea. You can look at the manual page for LS; it'll probably tell you.
Number of
So,
hard links is immediate subdirectories it has,
oh, okay.
including the one it's in or something like that as well.
Interesting. Yeah, because most of these are one. CSE would definitely be bigger. Yeah, okay, so something like that. So I know this is the owner, this is the group, this is the size of the file, and then a timestamp. And I don't know if that's creation or modification timestamp.
Is that size like, is that in bits or megabits?
That's in bytes.
Or just bytes? Okay.
Right, so AB or a test contains ABC. It's a total of 4 bytes. And if we look at its contents, it's got an A, a B, a C, and a new line at the end. So that's the 4 bytes. All right, and here it's telling me 4 characters. So directories, I think the minimum size on a directory is 4 kilobytes, and it goes up in chunks. And you can change the ownership on a file. So what are my groups? Well, I don't have a lot of interesting groups. So I should be able to change group to CD-ROM on this file in. And now if I look at the file in, its group is CD-ROM. And so now anybody who's in the group CD-ROM would be able to access this based on these permission bits. You can also change the owner, but you usually need to have root access to do that. You need to have administrator rights to be able to do that.
Is there like something you could have universally available? So like everybody can access it, Nick, all the students, as an owner?
So the normal way to grant universal access is through the world bits, but you can actually set up a set UID bit or a set group ID bit. And let me think if I have one of these set up somewhere. I might have one somewhere on the Linux machine for that. But basically you can set an extra permission bit, and this will show up as an S, I believe. And what that means is that anybody who runs this file will be running it as if they were user ID Nick. And so typically you do this with some system level programs that you want other people to be able to run as a system user. And you can set the user ID to be root and set this bit to say, hey, when you run this, you are running it as root. That's a potentially really dangerous thing to do. But sometimes there's good reasons to do it. So Rogue, for example, on the Linux server is set up to run as if you were running it from the group ID games. So when you run this game Rogue, the system will treat you as if you were in the group games. And that's set up so that the score file, right, which contains people's high scores, can be set up to have access for people in that group, but not for the world. So you and I can't go in and modify that score file by hand, but when we're running this executable, it will have access to, files as if you were user ID games or group games, and so you can access that file. So that's like a set group ID bit. Well, I think people are harshing on Apple here in chat.
Yeah, iPhone sucks. If you ever have to do any sort of development for iOS, you know it's a ginormous pain.
Yeah, I've never played with iOS development.
iOS 15 came out and our app went totally useless.
Yeah.
The only thing we had to do was just update Xcode. Like,
Okay.
we just updated Xcode and it worked, like, for no reason at all. It was,
That's nice.
it was good that it was easy to fix, but boy was it stupid.
But a
we had
pain
to-
that it broke.
Yeah, because all our users had to download a new version.
Yeah. All right, send me an attendance note on the way out, and we will talk about inodes and symbolic links and things like that on Monday. Talk about a few utilities like tar and gzip and find. Talk a little bit about sudo, and then switch gears and start talking more about strings and character arrays in C. All right, have a good one. I will see you next time.